Math 3, Section 3, Unit 7, Part 2. So last time we talked about choosing points on a parabola. We realized that when we choose points, we have to check to see if they're equal distance or equidistant from each other, right? So they have to be equidistant from, the point has to be equidistant from the point to the directrix and the point to the focus, okay? And so there are some points that are very easy to find, but other random points, like on this line, are very difficult to find, okay? Or I should say curve. So we went through and figured out that the only way we could actually find, if we were going to choose a point to check if it worked, was by using the distance formula. So we picked a point, we checked how far the distance was from the point to the focus, then we checked to see how far that point was to the directrix, and we got close, but we didn't quite find them. So then we realized that formulas are much better than just choosing points. And so we basically did our formula by using a generic point, which we would use as just xy. We still had our focus point. And then your directrix point, because the directrix is actually a line, we use x, because whatever value for x you're using in your point, you use that same value for x in your directrix point, because the directrix isn't a point, it's a line. And so we plug this in, and we're always trying to find the same distance. Point to the focus is the same as the point to the directrix. And so when we did that, we plugged in all of this information into this equation, and we found the equation for this parabola was y equals 1/12 x squared, which should look familiar to you, right? And if we were graphing this, the vertex would be what? 0, 0, and we already found that vertex, right? Now, this 1/12 here is going to play into what we're going to be talking about today, okay? But after we found this equation, then we're like, well, now we could choose any value for x, which we chose 1, and then we can plug it into the equation and find the exact y value. So we were able to choose a whole bunch of points that we knew would for sure work, okay? All right, so moving on today now. We have part 4 here, general formula exploration. Okay, oh, is that where we're at? Yeah, okay. So the first thing is we want to let C equal the distance from the vertex to the focus. Okay, so where is our vertex? For this, we're using the same problem.
Oh, 0, 0.
It was at 0, 0, right? And so the distance from here to here, so the distance from our vertex to our focus is C. So if I were to write this as an ordered pair right here, what would we put for an ordered pair? So we're going to use C. So if this distance is C, that means that this point is where? Very good. This is 0, C. Okay, so we have now labeled point F on the diagram. Okay, on the y-axis, find an expression in terms of C for the total distance from F straight down to the directrix. Okay. Okay. So this is the directrix, right? So remember how we talked about how they're equal distances? Yes? So do we know how long this will be?
C. Yes.
C. You guys are amazing. Now, if both of these are C, how long is both of these?
2C.
Very good. Okay, so how does this expression relate to the distance from point P to point D, which we just talked about was 2c? What does the definition of a parabola tell you about the distance PF and PD? It tells us that they are what? Good. Okay, and so now we need to label point P in terms of C and label point D in terms of C. So basically everything here is equidistant, okay? So this right here is also going to end up being 2c. So could you, and we know that like this distance is 2c, and at this point right here, it is 2c. So what would this point here be?
2c? Or no, 2c.
Very good. 2c, because we're going over 2c and then up c. What will d be?
2c negative c.
Very good. Okay. So it says to add, oh yes.
Is it 2c because it's the measure of like the original c combined, or like doubled basically? Okay, I was just making sure.
Yeah, they're all like the same distances, right? So like
Yeah.
if this is c, this is c. If this is c, this is c.
Yeah.
Okay. Now, so if this point here, they want us to label, because we know this is a parabola, right?
Mm-hmm.
And so there is going to be the same point on the other side. And so this is quadrant 2 over here. So add another point Q in the second quadrant that would also have to be on your parabola. So if we add the point over here, we're going to label that as Q. And what would be that ordered pair? Negative 2c, c is correct. Okay, and what would this distance be? Good. And so I'm going to go ahead and kind of sketch this parabola here. Okay, so what is the total distance from Q to P?
4c.
Very good. Oops, you can't see the writing. Okay, so the total distance is 4c. So your new formula for the width of a parabola at the focus is 4c. So number 9 says, check this conclusion with your original parabola. So in the original parabola, what was our focal distance? So if we go back here, what was this distance right here? 3. Okay, so C equals 3, and so that means that our width would be 3 times 4, which is 12. Okay, let's go back and look at this. So if you count across here, this, what I said was the focal chord. See how it's at negative 6 to 0? That's 6, right? And then here to here, that is, and 6 plus 6 is 12. And so if you look at our equation, if you went back to the original equation, you know here how I had x squared equals 12y. We like to write it in this form, but you can see you have the 12 there. Here we have it written, our equation is y equals 1 over 12 x squared. So that means for your distance, the 1/12 represents our 12. Does that make sense what I'm saying? And so if this said, let's say 1/6, you would end up going how far on each side of your focal chord? 3 and 3, right? Because it ended up needing to add to be 6. So this ours adds to be 12. So does the formula width work in this case, in our original example? The answer is yes, it did work. We just went through and showed you how everything worked. Okay, so again, this is to remind us that this is basically our width at the focus. Okay, questions, anything you want me to go back through on this page? We're good? Yes? Okay. So we're going to go on to part 5 now. Okay. Using the definition to get the standard form of parabolas with the vertex at 0, 0, we know a few things. Okay, first of all, we know that this distance is what? C. Okay, which means that this distance down here is also C. And they've labeled this point right here. We don't know what our x value is right now because we're just choosing a random point as xy. And so the x value on the directrix is x, but the y value would be -c, right? Okay, so using this information, we are going to plug it in here and solve so that we can kind of get our generic form of the parabola. So on the previous page, we just found it for the exact parabola that we're dealing with, right? So we're going to plug in these points now using C versus using the number 3 that we used before. Does that make sense? Okay. So we're going to plug in the values. And again, if you want to label these to make sure that you're putting them into the right spots, you can. Okay, so here we're going to write what? Okay, 0 minus x equals, and actually, can we change that? I think I want to start with x. You'll get the same answer. We're just going to get lots of negatives if we start with the other one. So let's do x minus 0 so that we don't get a negative x. Okay, so x minus 0, and then we would have, good. And then on the other one, we're going to have x minus x, and then y minus negative c. Okay, so we simplify that, and we end up with x squared plus y minus c squared equals, and then over here we end up with 0 squared plus, and that will be y plus c squared. So far, so good? Okay, so if we go through to simplify this, we want to get rid of our square roots, right? So what do I do to get rid of the square root? Good. So we square both sides, and we end up getting x squared plus y minus c squared equals y plus c squared. Okay, and just like we did previously, we need to multiply these out in order to combine like terms and solve for our equation because we want to get all of our y's together, okay? So I would use your FOIL or the box method. Which way do you guys like better? The box? Okay, so we'll do a box over here, and we're multiplying out y minus c and y minus c. That's going to be on this side. So see how this is y minus c squared? We're going to multiply it twice. Okay, so y times y is y squared, and then we get negative cy, and then a positive c squared. So when I end up writing this out, I have x squared still plus y squared, and then 2 negative cy's makes a negative 2cy, right? Because it's like -1 plus -1, so negative 2cy plus c squared equals, and then we can make a box on the other side here for our c plus y, or y plus c. So we have y squared, cy, and c squared. Okay, and these are also like terms. So when I write this one out, we have y squared plus 2cy plus c squared. Okay, anybody confused on any of that? And then we know that anytime you have like terms on both sides, they end up what?
Cancel.
Good. Okay, so that means what's going to cancel out?
Y squared and c squared.
Good. Y squared cancels out, and c squared cancels out. Okay, so we want to end up getting y by itself, and so I'm going to add 2cy to both sides. So we have x squared equals 4cy. And then what would I do in order to get y by itself?
Divide by 4.
Divide by 4c, right? So these cancel. So we have y equals, and normally 4c, it represents a number. And so I'm going to pull that out as a fraction. So we have 1 over 4c x squared. So y equals 1 over 4c x squared. Okay, so knowing this gives you a ton of information. Okay, so we know that 4c is the width of the parabola at the focus. Okay, so it's going 4c across, right? So if you cut the 4c in half, you go that distance to the left and to the right, which makes it the total 4c distance. We also know whatever c is. So if you have, let's say the number is 8 here. Well, in order to find the c distance, what would you do? You take 8 and divide it by 4, which would give you 2. So the distance to the focus would be up 2, and the distance to the directrix would be down 2. Does that make sense? Okay. We're going to move on. Are you guys ready? Do we have questions on this so far? Ask me, Jordan.
Okay, you saw my face. We're not going to have to like graph these, right? We just have to do the equation for right now.
Oh, no, we're going to graph them.
Darn. Okay, never mind.
You'll be okay.
Oh, joy.
Oh, how funny. And there's 8. Okay. So we're going to do some practice problems here. So graph the parabola, y equals 1/8 x squared. Find and graph the focus, the directrix, and focal chord endpoints. Okay, so, and I don't even know why they don't have the vertex there, but let's go ahead and we want to start, we need our vertex, right? And so what is my vertex on this problem?
0, 0.
Very good. And we know it's 0, 0 because with the x squared, nothing's in parentheses, adding or subtracting, right? And if there was, we take the opposite. And then nothing's being added at the end, and so the y value is 0. So our x is 0 and y is 0. We're good then. Okay. So 0, 0, there is my point there. Okay.
Are they all going to be parabolas?
Yes, these are parabolas that we're dealing with. Yes. Okay. So we know our formula is y equals 1 over 4c x squared. Correct? So we know that the bottom represents, we can use this formula, 4c equals 8. Is everybody okay with that? Okay, 4c equals 8. So we divide by 4 to both sides, and we find that c equals 2. So with that information, can we find our focus and directrix? Yes, what do I do?
Why are we taking the answer from the previous problem and using it on this one?
Why am I taking the answer? This is like your generic formula right here.
Okay.
And so we know that this bottom
Okay.
represents 4C. So we can use this on every single problem.
Okay.
Okay, so we can find what C is. We can find our focal distance and our directrix by knowing this bottom number here.
Distance formula?
Kind of, yes, exactly. So we know that C is 2. So remember, if you go back and look through this, we talked about how it goes up C distance to the focus, down C distance to the directrix, and then it goes 2C across this way and 2C across this way in order to get that whole distance. Okay? So, going back to the problem that we were on. How far will I go up in order to get my focus? 2. So we're going to go here, and that is my focus. So let's write that ordered pair. What is that ordered pair? 0, 2. Okay, we can also find the directrix by going down 2. And this is a dotted line. Okay, and that is an equation, and the equation is y equals -2. Now, do you remember how far out we go? To the right and to the left from your focus?
You go up 6, right?
2C.
Oh, that's right.
Right? And remember that this, our focus, they have to all be the same distance, right? The points that you put on there has to be the same distance to the focus and the same distance to the directrix. And so since this is 4 right here, remember we can basically go out 1, 2, 3, 4 here, and left 1, 2, 3, 4. And this should add to be that bottom value. And does from this whole focal chord, does it add to be 8? Yeah.
So you're saying half the bottom number?
Oh yeah, half the bottom number, yes, because it's 2C. So yeah, so since C is 2, you can double that, or you can just divide that by 2, because that should be the total length. So what are my focal chord endpoints?
4.
Good, -4, 2, and +4, 2. Okay, and again, you can remind yourself that this right here is 2C, and this is 2C, which ends up making the 4C. And we know all those distances are C distance, C distance, C distance, C distance. Do you notice how this one right here is positive, which means that the parabola is going up? When we move to the next equation, the parabola, because there's a negative in front, the parabola is going to end up going down. What happens there is that the directrix and the focus end up flipping spots. So your focus is always inside the parabola. So if the parabola is going down, then the focus is going to be going down and the directrix is going to be going up. Okay?
Reflection?
Kind of, yes. Okay, so what am I going to do here in order to find my C value?
Get your
Okay, let's start with our vertex. Good. Okay, what is my vertex? 0, 0. So let's plot that. 0, 0. Okay, we know that the graph is going to end up going down. Okay, what's the next thing I should do in order to find my focus and directrix?
6 equals 4C.
Yeah, let's do -6. So 4C equals -6. So in order to find C, so we know our distance, we're going to divide by 4 to both sides. And we find that C equals, and let's write that as a decimal. What will that be? -1.5. So based on that information, we can find our focus and our directrix, correct?
C.
Okay, so where do I go?
go down
down 1.5, and I'm going to go ahead and put an F here because that's my focus, in case you forget. And the reason why is because the parabola is going to end up going down, and your focus is always like in the parabola. And then my directrix, we're going to go up 1.5, but that is a line, so we're just going to draw our dotted line there. Okay, so what is the ordered pair for my focus?
0 to -1.
Good. 0, -1.5. What is my directrix?
Y equals 1.5.
Good. Y equals 1.5. And then how do I find my focal chord endpoints?
Go up
Double
2C.
the total line, so B3, both sides.
Very good. So remember, it's always going to equal that bottom number, right? And so that means from my focus, and remember that you go to your focus, we're going to go right 3 and then left 3. Or we double the 1.5, which is also 3. And then you're able to draw your parabola. Okay, and then can we write those ordered pairs for the focal chord endpoints? So we have -3, -1.5, and then +3, -1.5.
That's just those 2 points.
Yeah, it's just these points on your parabola. Okay? All right, so it says for the parabola with focus 0, -2. Yes?
I have a question. What does the
Director?
yeah, that one. What does it do, like, exactly, besides just be there?
Is it kind of like the
It's kind of
vertical asymptote?
it's kind of like an asymptote.
Okay, so make sure, like, whatever direction that is, that's in your parabola is not going that way.
Exactly.
Okay.
Okay. I missed something.
Yeah, he did. He said it's border patrol.
Okay. All right. For the parabola with focus 0, -2, and directrix y equals 2, use the formal definition of a parabola to derive the equation in descriptive form. So remember that when we are finding our equations, we want the point to the focus to equal a point, the same point to the directrix. Correct? Okay, so we have the focus point, okay, and we have the directrix that we're going to make a point. And then when we're doing a formal definition, we use the point xy for our point. Okay, so just like before, so I'm just going to write this out here. So our point is xy, and our focus is 0, -2. And then again, my point will be xy, and my directrix is going to be what?
0, 2.
Close. We use the point, so the x, we're going to use x because we're going to use the point value, and then 2. Okay, so we're going to do x2. Because, like we said, the directrix is a line, but we're just choosing a point on that line. And again, it's generic, so we're just going to do x and then 2. Okay, when we are doing this, we have to use the distance formula, correct? Okay, so square root, and we're going to go x minus x, and we're going to start with the first point, so we don't have negatives that we're working with. So x minus 0 squared plus, then what's next?
Y minus -2.
Good. Y minus -2 squared equals, on the other side, the square root of x minus x squared plus y minus 2 squared. Good. Okay, so when we go to simplify this, we get the square root of x squared plus y plus 2 squared equals the square root, and x minus x is 0, so you can not write it, or you can write 0, plus y minus 2 squared. Next, what do we do?
Get rid of the square roots.
You square both sides. And so I have x squared plus y plus 2 squared equals y minus 2 squared. Okay, so then we need a FOIL or box, or maybe you can do this in your head since it's a number and not multiple letters. We have to multiply that out. And so, can you guys do it in your head?
Yes.
Y squared.
Y squared plus 4y
Good.
equals,
Plus
or plus 4,
plus 4. Good. Equals.
y squared
Mm-hmm.
minus 4y,
Mm-hmm.
4 plus 4.
Good. Okay. So again, we can cancel out any like terms, and so my y squareds cancel, and what else cancels? The 4's cancel. Good. And then in order to get these together, we're going to subtract 4y to both sides. So I have x squared equals negative 8y. And then to get y by itself, what's my last thing?
Divided by
Divide by negative 8. And so we'd end up writing this as y equals,
Negative 1/8 x squared.
good, negative 1/8 x squared. Any questions?
Can you just keep that?
Yep.